So what we're starting today is Chapter 2. We're starting Chapter 2.1 today. Now, last chapter, when we actually applied the functions, or we started talking about parent functions and their transformation, was 1.2. Because we talked about in the main ones we looked at was linear, quadratic, and absolute values. If they moved up or down, left or right, if it had a vertical stretch or shrink or reflection across the x-axis. We looked at really all three. We had a constant function, but we really didn't look at it. You can leave it. So we talked about those three ones. We did have constant functions, but we really didn't look at them. But we mainly looked at linear, absolute value, and quadratics in 1.2. But if you noticed in 1.3, we only had linear and absolute value. The quadratics were gone. Did anybody else notice that? Or it just stayed with those two that we moved up, down, left, and right, had a stretch or shrink that we actually applied to it. And the reason for that is because they actually left it for Chapter 2. We're going to apply those here. Now, the first piece of your note sheet is this here. How does the constant function a, h, and k affect the graph of the quadratic of this here? Now, really, we can think of it as is equal to a parentheses b x minus h squared plus k. And we look at this here, the k did what to it? It moved it up or down. Because when we had something added or subtracted to the end of it, it either moved the function up or it moved the function down. What did KH do? It moved it to the left or to the right. It moved it to the left or to the right. And those we dealt with a good bit in Chapter 1. Now the A also had a few. It talked about a reflection across what? The x-axis. So if it was outside the parentheses or absolute values, we're really talking about a reflection across the x-axis. We also had something else. It was a vertical, what? Stretch or shrink. And it was a stretch if a was greater than 1, and it was a shrink if it was between 0 and 1. And then if it's negative, it's just a reflection across the x-axis. Well, let's see here. Only one I haven't done is red. We did talk a little bit about B, but I talked about it originally as not talking about it much at all, and then we flipped back over and did. One part of this deals with a reflection across what? Across the y-axis. And then what else was it? Yes, horizontal stretch or shrink. Horizontal stretch or shrink. Because it's going to deal with one of those two there. And the horizontal stretch or shrink, and again, the reason I haven't taught it in years past, we've talked about it but not dealt too much with it, is because what do we have to do with that value? We have to flip it. We have to take the reciprocal of it. Because remember when we talked about it, transforming the function by a horizontal stretch at 2, we didn't plug 2 into the function, we plugged in what? 1/2, right? Because 2 becomes 1/2 when we flip it, we take its reciprocal. So it's always the flip. But this here really describes the general function. Any type of quadratic in vertex form, this here is described by this. And again, having this down, especially when y'all work on the homework, is going to be helpful because we can start pinpointing where is it at. Because if I have a value in front of x being multiplied by x inside the parentheses, it's going to be either what? A reflection across the y or a horizontal stretch or shrink. Because that's where it's located. If it's outside the parentheses and being multiplied by it, either by a set of parentheses or x, it's going to be what? Reflection across the x or a vertical stretch or shrink, because that's where the number is located. Add, addition, or subtraction inside the parentheses is a left or right. Outside is up or down. So the first few we'll look at really talk about horizontal and vertical translations. A horizontal translation is moving it to the left or to the right. Vertical, it's moving it up or down. And this is really stuff we've done before. So describe the graph transformation of the function x squared represented by g of x equals parentheses x plus 4 squared minus 1. And then graph each function. And again, we're not going to focus too much on graphing. We're just going to mainly describe the transformation. So what are the two transformations here? So we have left, how far? 4. Left 4. Well, we see that inside the parentheses themselves, yes? Because it's x plus 4. Inside parentheses is always the opposite of what we think. So plus 4 would actually be left 4. And then what else do we have? Down 1. Since we have the subtraction of 1 on the outside, it is going down. Because our up and down movement is exactly what we think. Minus 1 would be down. The x plus 4 on the inside is telling us it's moving to the left 4. And the reason that is because when we look at the general vertex equation, it says b times x minus h. So we have that minus h, yes? Well, what that really means is that here we have x minus negative 4 on the inside. So our actual value of h is negative 4, left 4. Because we could think about it this way, well, if it's negative, the h value is actually whatever that number is, and if it's positive, we have to really take that negative out to see what the actual movement is. Or we can just say it's the opposite of what we think, because it's always going to hold true. Because since it's positive plus 4 on the inside, it means moving to the left. What about this one here? Since it is x minus 3, negative 3 makes this thing to the left, so the opposite of what we think would be to the right. And that's it. Questions on this here? We good with this here? How about this one here? Since we have x minus 2 inside, it's going to be to the right 2. And the minus 2 outside would be down 2. As inside parentheses, it's the opposite of what we think. Outside parentheses is exactly what we see. Minus 2 is going to go down. Any questions on this here? All right. How about this one here? Left 5 and up 1. And that's it. Questions on this here? I think we're good with this, yes? We're good with left, right, up, down. Now the next thing we have is a reflection across the x-axis or the y-axis. Now if we notice with the x-axis, that negative is outside of the parentheses. It's in our a spot. So really if a is negative, it's a reflection across the x. Now if it's inside the parentheses, it's going to be across the y-axis. Now, this is similar to one of the problems on chapter 1.3, where we had the absolute value of negative 4x, because we did a reflection across the y-axis. And probably most of you looked it up in the back of the book and saw that it said it's the absolute value of 4x. They dropped the negative, yes? And this is coming into exactly why it would be the same thing here. Because when we reflect a point across the y-axis, its distance here will come across the same. If this is a distance of x, it's going to go x and map a new point. So really this point is actually, because of absolute values in quadratics, is going to go there. But this point is also going to be moved to here. Every point on the right side of the graph gets moved to the left, and every point on the left gets moved to the, and that really works with absolute value equations and quadratics as long as they are centered on the y-axis. Because once they're moved off the y-axis, it doesn't work that way. But when we just look at the function, negative x squared, well, we're saying that we have negative x times negative x, yes? Well, negative times a negative is a. So just having the function negative x squared is just the same as saying x squared. Even if I had negative 2x squared, since I don't have anything really added or subtracted, the negative really doesn't affect it. It's mapping it to itself. It's its own reflection. So really just having parentheses negative x close parentheses squared doesn't actually give us a new function. It's going to be the same as x squared. Vertical and horizontal stretch and shrink. Vertical stretch and shrink we have dealt with. We've talked about vertical stretch and shrink. Because if it's in the a's place and it's greater than 1, it's a stretch. If it's in that a's place and it's between 0 and 1, then it is a shrink. Now they gave us this here for horizontal. Horizontal stretch away from the y-axis where a is between 0 and 1 is considered a stretch, and it's a horizontal shrink when a is greater than 1. But again, when we talked about horizontal stretch and shrink, we're talking about 1 over. We had to take its reciprocal. We had to flip it. So if it's a stretch of 4, we're plugging in 1 over 4, yes? Well, 1 over 4 is between 0 and 1. So the actual value of the stretch is 4. What it looks like in the function is between 0 and 1. So it would look like it is a shrink, but it is actually a stretch. So if it looks inside that it is a stretch, it's actually a shrink. So it's still that opposite of what it looks like still holds true with inside the parentheses. So let's actually look at them and see how this works. This here is our first function. We have g of x equals negative 1/2 x squared. So we can see that the difference is that negative 1/2 x squared, yes? If there's a negative, it's only attached to one type of transformation, which is, now remember, do these deal with any type of negative? No? It's going to be a reflection. If we have a negative, so when we look at this here, even if it's outside or inside the parentheses, it's going to be a reflection if we're talking about the multiplication of a negative. Because if it's a subtraction, either minusing 1 or minusing inside, it's not a reflection. But if we're talking about kind of having this negative attached or multiplied, then it is a reflection every single time. So when we look back at this here, this negative being multiplied by x squared is telling me this is a reflection. So I can say reflection, but we have two types. Because it would be a reflection across what? Because it's either across the x-axis or across the y. It would be across the x. Why would we say that? Where is that parentheses? Is it inside parentheses or is it outside? Outside, isn't it? Even if they don't write parentheses in, it's outside. Because the only way that it can be inside parentheses is if there are actually parentheses there. So this has to be the x-axis. Well, that also tells me the 1/2 is not in the b's place. It has to be in the a, because b is inside parentheses. There aren't any parentheses for it to be inside, so it has to be a. So that is a what? Vertical, what? Stretch or shrink? Shrink, because it is a factor of 1/2. As again, when we start talking about multiplication with x inside or outside parentheses, it's going to be our stretch or shrink. Inside parentheses is horizontal. Multiplication of a number outside parentheses is vertical. Any questions on this here? We'll move on to the next. Here we have 2x squared plus 1. What would be an easy one of the transformations for us to describe first? Up 1, yeah. No matter what we do with vertical stretch or shrink, reflections, up and down is going to stay the same, which is nice. Yes. It would be a horizontal what? Shrink of what? Exactly 1/2. Because again, when we plugged in the horizontal stretch and shrink, we had to flip it, yes? Because it told us a horizontal stretch of 2. It got plugged in as 1/2 because we had to have 1 over it. So here, I would look at it first and say, okay, it's inside parentheses and we're multiplying by x. It's in the place of b. So it has to be a horizontal stretch or a horizontal shrink. Okay? We know that for sure. And I look at the number and it says that it's 2, yes? But we have to do what to it? So really we're talking about a factor of? Is 1/2 dealing with stretch or shrink? Stretch is greater than 1, shrink is between 0 and 1, yes? So it is a shrink. Now, you're probably also saying exactly, Callie, well, on the notes, if I go back here, it says stretch is between 0 and 1, and shrink is greater than 1, yes? But we just said the factor was what? 1/2. Well, that would be talking about this here is purely talking about the 2. The 2, because 2 is greater than 1, which according to that picture, according to that how it's set up, would be a shrink. But if we flip it and actually look at the factor as 1/2, then it lines back up with what we're saying. Shrink is between 0 and 1. Stretch is greater than 1. Does that make sense? And I think that's a little bit easier to keep track of. Once I see, okay, 2, so our actual factor is 1/2. 0 and 1, shrink. Greater than 1, it will be a stretch. Let's look at this one here. So what do we have? Yes, and why do we know it's x and not y? Outside parentheses. What else? Vertical stretch of 3. Because again, when we look at that -3 out front, the negative deals with the reflection. The 3 deals with the vertical stretch or shrink. Because those are separate. We look at them separately. Questions on this here? We good with this here so far? Now, the big thing I would say with this here is really going back to our general equation. where do each one of these fall? Where do they match up? The -3 matches up with our A. A deals with vertical stretch or shrink or reflection across the X. That's where that lines up. B, inside parentheses multiplying by the X is a reflection across the Y or horizontal stretch or shrink. If we have a -H, plus or minus number inside the parentheses, it is left or right. If it's outside the parentheses and we're adding and subtracting, it's either up or down. And this here, the other little caveat is that we don't have x to the first. We don't have an x to the first. Because it's either in parentheses squared or we just have an x squared term. And we'll deal with those other types later. Let's look at this here. Well, we have two different transformations happening. What's the easier one down to? Yes. So we know it is horizontal because I have 1/4 x. Now, the actual scale factor that we're dealing with is 4, because 1/4 is in there, so we have to take its reciprocal. We have to flip it back to 4/1 or just 4. Is 4 between 0 or 1 or greater than 1? Greater, so this would be a horizontal stretch of 4. That's it. Questions on this here? What would this one be? Because since it's inside the parentheses and we're multiplying by x, it will be a horizontal stretch or shrink. So our actual factor would be 3 because we have to flip the 1/3. And it would be a stretch because when we're stretching it horizontally, it means it's increasing faster along the x-axis. Well, this one here, I graphed it in first hour, and I'm going to go on and do it again here. I'm going to show you the graph. Now, I will tell you this here. 0, 0. The origin will still be the origin for our new one. That will still be a point on the graph. Now, normally when we graph a function, we go -1, 1, -2, 2. We pick points going out. That won't be as helpful here. I'm going to pick 3. Well, what is 1/3 times 3? 1. And 1 squared is 1. If we did the same thing at -3, well, -3 times 1/3 is -1, and -1 squared is 1. Well, what's happening? It's increasing faster along the x-axis, yes? If we did the same thing at 6, well, 1/3 of 6 is 6 divided by 3 is 2. 2 squared is 4. And at -6, we will also get 4. So it's increasing faster along the x-axis, yes? It's increasing slower along what? The y-axis. So it looks very similar to a vertical shrink, yes? Now, interestingly enough, it's actually, let's do a different color. Say 1/3 x squared, and the function we have here, parentheses, 1/3 x, close parentheses squared, actually don't give us the same function. So we would still get 0, 0. That won't change. But if I plug in 3, 3 squared is 9, yes? And 1/3 of 9 is 1. Well, that's already higher up, isn't it? And it will increase faster. So So wait, what number did I get out? 9 instead of 3? So the actual vertical shrink that would align up with this would not be 1/3, it would actually be 1/9. Well, how is 1/9 and 1/3 connected? Because what times 3 is 9? So I did what? Squared it. To get it out of the parentheses, I had to square it. That's just a side note. It's not really big importance. So as we can see here, that 1/3 horizontal shrink or horizontal stretch is not going to be the same as vertical shrink of 1/3. It would be 1/9. So they're not completely interchangeable. They do have a different effect. Any questions on this here? Do we feel comfortable with this? Yes. It is. Let's look at this last, well, we'll look at this one here, and then I'm going to throw another one in. So what are our 3 operations or transformations? Up 2, up 3, and a reflection, and I'll move across the x-axis. And really, we're just lining up where they appear in each spot. Any questions on this here? Now, I know that this is the end of the note sheet, yes? That there's, well, there is more to the note sheets. That's where we're stopping for today in the note sheet itself, because I split these apart. But that's not where we're stopping total. Come on. I'm going to write this function down. Okay. Bring the note sheet back up. Okay. So the last function I want to look at is this here. Now, we'll deal with the reflections and the horizontal and vertical stretch and shrink, because we see there is both of those in 2 reflections. What about left and right, up and down? Up 8 and right 4. Okay. Now this here is Desmos. I have talked about this before if you've been in the geometry class, or I've mentioned this. This is a graphing calculator. It will graph function for us. So we know 0, 0 hits the lowest point. So as we saw, the -4, so it's moving it to the right 4 and up 8. Now there will be some reflections, but the lowest or highest point where it kind of curves down to should be right 4 and up 8, yes? So I can tell it to go on and graph. Well, this here is the point, isn't it? But it's at -2, 8, isn't it? So it's not moving to the right, it moved to the left and up 8. We're halfway right. Yes, we had the up 8 correct. Okay. Come on. Now again, I talked about how in last chapter how horizontals, stretch and shrink, really mess with the graph, how reflection across the y-axis really messes with the graph. So what we have to do, now this, what I'm going to say is only if I have both of these, either a horizontal stretch and shrink or a vertical stretch, or a reflection across the y-axis and a translation left and right. If I have the reflection across y and a translation, a horizontal stretch or shrink and a translation, or both the reflection and the horizontal stretch and shrink with a translation, we have to do this. I have to factor that -2 out of both terms. Well, negative 2x divided by negative 2, anything divided by itself is 1, yes? So we just have x. What's negative 4 divided by negative 2? Well, negative and negative make a plus. 4 divided by 2 is? Well, wait a minute. Plus 2. Opposite what we think, it's going to the left. How far? Does that line up with the graph now? Because the point where we said it was at negative 2, 8. Left 2 and up 8. Now it lines up. So if we see here that horizontal stretch and shrink in that reflection really messed up what that horizontal translation was. So we don't normally see too many of these here connected. You might see these in college algebra where they'll hook these two together. But really all we did was what? We pulled that negative 2 out of both terms inside of it. And now it's back to what we had before, isn't it? I'm going to do the first part and explain it because we do have a reflection across what? The x-axis, yes? I'm going to be lazy. Because the one on the outside parentheses, that negative is across the x-axis. The negative 2 is telling me it's also across the y-axis. Why rewrite a reflection across twice when I can write it once and explain both? The 3 would be a vertical what? Stretch of 3. We've taken care of the negative 3 on the outside. We took care of the negative for the 2, but the 2 itself would be a horizontal what? Shrink of 1/2, because again we have to flip the 2 from 2 to 1/2. How about left? How far? 2, and last but not least, okay. And that's it. So realistically, did this, having the reflection across the y and the horizontal shrink of 2, really mess with what we were doing? Not too much, because once we pulled that negative 2 out, it's back to what we were doing, yes? Just looking straight at it. And again, like I said at the beginning of the year, Algebra 2 in and of itself is not overly complicated. It has lots of easy little steps. It goes factoring out of 2. We've done that before. You've done it in Algebra 2, yes? But it's remembering to do it. As long as we remember to factor that out when we have it with a horizontal translation. Because if you notice already earlier, because we had, one more, horizontal shrink, or horizontal stretch here. Did that affect the translation? Well, no, we didn't have the translation. We didn't have to do anything. It is only when that stretch or shrink horizontally is connected with a horizontal translation. Once those are connected, then we have to do that factor out. But if they're not connected, we don't have to touch it. We don't have to do anything with it. But that